Welcome to this week's Tech Tip Tuesday, where we're going to take a look at some of the mold tools found in SOLIDWORKS. These tools can be found in the Mold Tools tab in the Command Manager. For simplicity's sake, today we're going to just focus on generating parting lines, shutoff surfaces, parting surfaces, and we'll take a look at the Tooling Split tool. The rest of the tools found on the Command Manager are great for advanced case scenarios, but we'll take a look at those in a future video. So let's go ahead and get started. The mold tools are great for plastic injection molded parts as well as castings such as this switch cover. But to get started, the first thing we need to do is establish where our tools are going to split. And by tools I mean the core and the cavity, or the top and the bottom, whatever your language might be. To do this, we're going to use the Parting Lines tool in SOLIDWORKS. The Parting Lines tool needs us to specify the direction of pull. This can be done with any flat or planar face on the model or any plane in the Feature Manager tree. In this case, I'm going to select the top plane. The direction of pull is then graphically displayed by an arrow on screen. This shows us that the cavity or the top half side is going to be pulled up. Obviously, the core or the bottom half will be pulled away, or it'll actually be fixed in place on the injection molding machine. Once we've done this, we want to go ahead and find the parting line on the model. Now, using SOLIDWORKS' built-in draft analysis, as long as you have draft in your model that exceeds the value in this field, SOLIDWORKS should be able to find the parting line for you. If it doesn't, let's go ahead and deselect some of these lines to show you how you can go ahead and do a little bit of this on your own. You'll notice that once you select an edge on the parting line, SOLIDWORKS presents an arrow. Now, you can go ahead and select the edge manually that's been applied, or in the Property Manager, there's an Add Selected Edge button. And you can use this to kind of follow along the part and manually select the parting line. Now, anytime you're using these tools, SOLIDWORKS is always presenting you a message. In this case, it's telling us that the parting line is complete, but it currently can't separate the core and cavity because it might need shutoff surfaces. So SOLIDWORKS is looking ahead to determine if it's going to be able to generate a tooling split already for us. So keep an eye on these messages as you're working, as they give you a lot of insight. Finally, if you need to manually split faces, you can choose the checkbox here to go ahead and split any of those automatically, and SOLIDWORKS provides a manual split option down at the bottom, which again we'll look at in a later video. So let's go ahead and let's generate our parting line. It's very clear to see in the model. It's very graphical, so you can see where that parting line is at any time. But this part happens to have 3 holes that run through the middle of it that's keeping a mold from being separated. These need to have shutoff surfaces, so let's use the appropriately named tool. SOLIDWORKS looks at the direction of pull and then looks for any holes in your part and automatically chooses the edge it thinks is best. Now, in this case, it's actually what we want, but what if you wanted to make some changes? Or what if SOLIDWORKS missed a hole or two? You can at any time deselect or select any edges to add to this, but notice that the message has now changed to the mold is not separable. Please select chains of edges to identify shutoff holes. As we select the top edge, we've reestablished a watertight model in this case. On each edge, SOLIDWORKS also provides a callout, letting us know how it's going to generate the shutoff surface. A contact surface tries to be as flat as possible, where clicking on this will change it to a tangent type. Now, a tangent type will generate a bit of a bulge or a bubble, and you can see here I've changed the direction and it's very clear. That's not what we want in this case, so let's click it again and we'll see that there's a no-fill option. No-fill option is basically a fake shutoff surface to meet the requirements of the message without actually generating a surface. But again, that's a more advanced topic. Let's return to a contact type. Better yet, let's deselect this edge and reselect the previous edge on the bottom of the part. Likewise, all of those options can be changed by pressing any one of these 3 buttons to None, Contact, or Tangent. This applies to all of the shutoffs in one click. So let's go ahead, press OK, and at this point SOLIDWORKS has done something really unique. You can see in the Feature Manager tree it's now generated folders for surface and solid bodies, and this is because there's multiples of either one. If we expand surface bodies, we can see that there's two unique folders called core surface bodies, and what SOLIDWORKS has done is it's generated a series of surfaces that represent the bottom half of the part. It's also created a cavity set of surfaces which represents the top half of the part. These are going to be used in combination with the next feature we're going to generate, the parting surface or the mating surfaces of the tool itself. So let's go ahead and click that button and see how it works. The tool starts generating a shutoff surface, or a parting surface along the parting line that we had generated previously. It does this by creating what's called a ruled surface along that edge, but we have a lot of options where we can change this. Let's go ahead and start by increasing the depth of this to say 20 millimeters. When we do that, we have a few other options. Do we want to smooth out any of these edges, or do we want them to be sharp? And you can see how they kind of snap to more of a sharp edge. We want to smooth those out as much as possible to accommodate any machining operations we might apply. Likewise, in some cases, you might get surfaces that are a little less than desired. You can always check the checkbox for manual mode to have much more control over these parting surfaces. As soon as we do that, a series of guidelines are established for every node at the end of the surface. And just by doing that alone, it's really cleaned this up. But let's take a look at what we can do. You can grab any grip at the end of one of these control lines and drag it out, and you can see that it changes the way SOLIDWORKS will generate the parting surface. Furthermore, if you drag any of these grips out to be either horizontal or vertical to the point it's coming off of, you can see that the node changes from magenta to black. So it snaps into position, making it really clear how these go together. And in this case, we may want to drag this node back in. You can see we can make changes. I'm not comfortable with the way that is, so let's return that to where it was. We now also want to deal with this arc right here. The tool is doing just what we told it to. It's offsetting out 20 millimeters, but we want a nice smooth surface across here. And to do this, we're going to do what's called a fill. You can right-click on any node and choose to start a filled surface region. And then if you right-click any other node and choose to end the fill surface region, SOLIDWORKS will basically fill in any holes or gaps across that surface. It makes a really smooth surface and makes the next process we're going to get into a lot easier. Now, I've generated a parting surface at 20 millimeters, but at some point we want to take into consideration the outer boundary of our actual tool. If we want to avoid any additional surfacing work later on, it makes sense to extend this beyond that where the tooling boundary is going to be. So I'm going to increase this value to 60 millimeters. But in some cases, this doesn't always work. In that case, you may need to resort to some manual surface creation. But this looks good for us, so let's go ahead and press OK. SOLIDWORKS has now generated a third folder in the Feature Manager tree called Parting Surfaces. SOLIDWORKS is going to use the parting surface in combination with the cavity surface to generate the top half of the mold, and it's going to use the parting surface in combination with the shutoff surface to generate the bottom half. This can be done within the same part file using Tooling Split. When we press this tool, all we need to do is either draw a sketch or select the one we've pre-created. I always recommend pre-creating this as it makes it easier to understand how big the parting surfaces need to be. Then simply specify how much material you want on either side and then press OK. SOLIDWORKS has now created a multi-body part file. You can see we have three solid bodies, the original part, the core half, and the cavity half of the mold, as well as all of the original surfaces. So this is a nice compact way to store all the geometry, and we can right-click and isolate each solid body to get a good look at this. But I want to go into one advanced tip. Some users don't want to create all their bodies inside of a single file. They want to do this in the context of an assembly. So let's go ahead and delete the tooling split and see how we can accomplish this. I've already started an assembly that has material that represents the core and cavity. However, this material doesn't have anything on it. I actually have an exploded view created, so let's go ahead and separate these. You can see they're just solid blocks at this point. What we need to do is we need to transfer those surfaces into that part file. So let's go ahead and collapse this assembly and see how we can do that. All we need to do is choose to edit the part and copy these surfaces into that part file. Now, to do this, we're going to use Offset Surface. Now, as soon as I start selecting surfaces, there's a few things to notice here. SOLIDWORKS is actually offsetting the surface, so we want to actually change this value to 0. We actually just want to copy the surface. Likewise, we don't want to have to select each surface one at a time. That would take forever, and it could be very complicated on a complex part. A useful trick here is to use your filters to filter surface bodies, and in this case it selects all the surfaces of that surface body in one go. Now, this is just going to capture the parting surface. We have to do this twice. We also need to capture the cavity surfaces that were created. Now, you can see that SOLIDWORKS with this filter turned on makes it really easy to go ahead and grab this through this part, but I'll show you another method. You can actually go into the Feature Manager tree, into the switch cover part, expand the surface bodies, and find the surfaces that were created by the mold tools in this way. We'll then right-click and add those to that file. Let's go ahead and clear our selection filters and open this part up. So we can see that we have a solid block that contains these surfaces in it. One of the things we need to do is we need to knit these two surfaces together. So I'm going to pre-select them and choose the Knit Surface option and simply press OK. Finally, we want to cut with these surfaces. To do this, I'm going to use a surface tool called Cut with Surface. It's not on my command manager, so I'm going to use Search for Commands to find it. And I'm going to simply drag and drop it and add it to my command manager. Then, using the tool, simply select the surface body and keep an eye on the direction it's going to cut. In this case, we need to flip it. And then press OK. And because we're done with the surface body, I'm going to choose to delete it. You could likewise hide it if you wanted to. And we've generated our cavity. Let's see that all again. I'm going to go ahead and close this and save it. And we're going to take a look at the bottom half. Again, I'm going to select it and choose Edit Part, Offset Surface. And in this case, I'm going to simply expand the Feature Manager tree. And I'm going to grab the core surface. And I'm going to pre-select this time the parting surface, and again choose Offset. And we'll go ahead and open this part up. Again, we need to knit these two surfaces together so that they're one, otherwise the cut with surface operation won't work. And now we're going to run into another problem. If we choose cut with surface and there's no material for it to cut above it, we're going to fail. What we'll want to do at this point is change this extrusion to make sure it extends beyond those surfaces. An easy way to do this is to simply just drag this well beyond the area you know it's going to cut across. Now when we use cut with surface, we select it, make sure the arrow's in the right direction, and then press OK. Again, I like to delete the body once I'm finished with it. Some people like to hide it. And there's our bottom half of our tool. Let's go ahead and close this and save it. Let's go back to our exploded view of our assembly that we had before. And in this case, we can go ahead and hide the rest of these surface bodies, not the component. How about the bodies? Let's go ahead and right-click and choose to hide them all at once. So there you have it. There's now an assembly, and we can start generating holes and features for ejector pins and cooling lines and all the other parts that are necessary. Hopefully this Tech Tip Tuesday was useful, and I'd like to revisit this set of tools in a future video to look at some more advanced topics.